Okay, this is our first EDA tutorial. I'll go to, after you install Xilinx under your program, you can find out this guy, Xilinx ISE Design Suite. And here, go to ISE and go to Project Navigator. Unfortunately, my computer is very slow. And normally, the first time when you use the ISE, the Xilinx ISE environment, it will ask you to kind of install a license or enter license information. So if you are required to enter any license information, you can go to Program, Xilinx ISE, and here we have the option Manage Xilinx Licenses. And I have already imported my license. So what happens is on Blackboard, let me see if I can get internet. Okay, great. So on Blackboard, we have this folder named as Xilinx. Go there, and this file is the license file. You can either generate this file online from Xilinx website, or you can download the license file. This is my license file from Blackboard. After you download it, you simply need to click this button, Copy License. And then you point to where you download the license. Like, for example, in my case, I have my license downloaded right here. So I simply need to double click this Xilinx.lic. Then the license will be automatically populated into this table. And after that, you can close it. Then you have the license set up. So once you have that, your Xilinx window will look like this. So our first step, just like what we do on a lot of Windows-based software, we can choose New Project. And here we have to enter the name of our project. So this I will enter a name as EDA Tutorial 1. And here you can also specify where you want to save the project. So in my case, I created a folder named as Xilinx project under my documents. So that means in the future, all the projects I created will be saved under this folder. Okay. And the very important thing is on the bottom side, you have to choose schematic, because our first project will be based on schematic design. So choose schematic on the bottom side, then click next. And here you can choose different types of FPGA or CPLD you are going to use. So in the future, you'll see that you can actually get a very small FPGA chip. So based on what kind of chip you purchased, you can choose. And in this case, in our simulation, let's choose the family of Spartan 3E, which is a popular family of FPGA. And for the device, let's choose XC3S100E. And the next line, the package, means what is the package of the chip. Like on the chip you have multiple pins, right? So obviously 144 means this chip, it has 144 pins. And other things you don't have to change it. And one thing I want to mention is at this location you can choose the preferred language. So for FPGA design, there are two popular types of language. One is Verilog and another is HDL. And in our case, we are going to use Verilog. So I'll click Next. And on the next window, I have to specify what is my source file for my design. So I'll click New Source. And here I'll choose schematic. I'll do a schematic design, right? So for the schematic, let's name it as decoder 2 to 4. Click Next, Finish. So after that, you'll see this schematic file is already added to the project. And I have this decoder 2 to 4.sch, stands for schematic. Click Next. And you can continue to add existing files. In the future, you may have one project, and when you set up another project, you want to reuse the design in the first project, right? Then you can choose Add Source. But in this example, we don't add any existing source. So I click Next, Finish. So after that, I'll have this window, and on the bottom of this biggest window, I can choose different files. At this moment, I only have one file. It's called decoder 2 to 4. And on the left side, this is a navigation window. You can choose different ways to look at your project. You can look it as a design, or you can simply look at the files that you created for the project, or you can look at the libraries, right? Different options. And you can also double click, if we have the design here, we double click this, it will bring up the schematic window on the right hand side. So here we go. And the next is we have to add the component for our design, right? And for the 2 to 4 decoder, it's really simple. We only need 4 AND gates, and we need 2 inverters. So I'll go to the last tab on the left hand side, Symbols. And here under the symbols list, I can go down and find out AND2. So this AND2 stands for AND gate with 2 inputs. After I click that, I move my mouse to the right hand side, and I can add the AND gate. I'll add 4 AND gates like this, and I can use the center button of the mouse to zoom in and zoom out. If I push the Control key and use the center button, I can zoom in, zoom out, or you can use this to zoom in, zoom out, whatever you prefer. Okay. All right. So it's really simple. And now I have to find out inverter. And for you guys who are using laptop, feel free to stop me if you can't follow me or if you got stuck on any step. Okay. So I'll go down and go down, look for my inverter. Okay, here we go. This INV stands for inverter. So I'll put 2 inverters. Okay, then once we have those components, the next thing I want to do is to use wires to make the connection. So right here, we have a lot of buttons, and one of the buttons represents wire. So this one, if you keep your mouse here, it will tell you add wire. So you can click this button, or in the future you can use Ctrl W, which is the hotkey for add wire. So I'll make the connection like that. If I don't remember the connection, I can go back to check the schematic. So for the output of the first inverter, I have to connect it to the first AND gate and the third AND gate. So I'll do this. And for the output of the second inverter, I have to make a connection from here to the first and the second AND gate. So from here to here, and from here to first one. Okay, well, it's a little messy, but you can drag the wires around to make it look nice. I'll simply delete it. Okay, makes a connection like this. Alright, and for the input of A0, I have to make a connection from A0 to the second and the fourth AND gate. So the second is right here, and this is the fourth AND gate. And for A1, I have to connect it to the third and the fourth. So from here to here, and pretty much that finishes the wiring of the components. Okay, after we finish the wiring of the components, we have to denote the input and output, right? So I can choose this button, add I/O marker. Then I can add the markers for the inputs, output. And I also want to rename them so that I can easily understand my function. So I double click this and choose nets and change the name from the default name to A0. Likewise, I can change the name A1, change this name to D0, D1, D2, D3. Okay. So that's all I can do on the schematic. And the last thing, very important, when you want to claim your credit for the project, remember to add your name. So I'll click this A here and move it to the schematic, double click it. I'll change the text font size to be large so that everybody knows that I designed this. And I can change the text value to my name. And in your case, it's gonna be your name. So I'll write down my name, designed this. Okay, and make it real big. And this is important because when you submit the project, I have to tell it's designed by yourself, not copied from somebody else. All right. After that, I think pretty much that's all we have to do on the schematic. So now I go back to the design here. I select this component, and on the bottom side, there are several choices. The first choice, I can synthesize this design. In the future, we will learn what is the real meaning of synthesize. But for now, you can understand it as once you design this, you have to tell the computer what I designed and ask the computer to synthesize those functions. So after it's done, you will have this green check over there. And the next thing is implementation. This we will learn in chapter number 3. So basically, based on the schematic, the computer have to translate this design into the real transistors. So it will do translation, mapping, map it to the gates that the software is familiar with, and then place and route. So those are more like physical level design. We tell the computer the logic based on the schematic, and the computer will automatically generate the physical design. And later on, if you purchase the chip, you can download this to the target device. Then the small chip will have the function we specified here in the schematic. Okay, so that's all on the implementation. And the next thing we want to do is to simulate if the circuits really perform as what we want, if we can really generate this kind of a function as denoted in the truth table, right? So to do this, we have to go to project, add source. We have to add, project, new source. We have to create a test bench for this design. So this design will be in our chip. And let's say if this is my chip, the design will be realized inside the chip. And we have to create a test bench to feed in the signal, and we have to analyze if the output signal makes sense. So to do that, I have to choose Verilog test fixture here, and I name it as decoder 2 to 4 TB. TB for me, it stands for test bench. Click next, next, finish. And after that is done, you will see that Xilinx is nice. It helps us to create this initial program to set up the input, set up the output, set up the wire, and initialize the chip. And when the chip is initialized, see here we have the initial, begin, end. So when the chip is initialized, both A0 and A1, they are zeros. And now I have to change the code. Like if I want to test whether my output will be the same as specified in the truth table, I have to generate different combinations of the input, right? So here I will type initial, begin, end. So the things within this begin end section will be my control for the input signal. So first, I still keep A0, A1 to be 0. And the next, I will use number sign 10. So this number sign 10 means we want to hold the signal to be 0, 0 for 10 nanoseconds. And the reason I don't have to tell the software it's nanosecond is because at the beginning of the program, we already told the software the time scale is 1 nanosecond and the resolution is 1 picosecond. Okay. So after we hold for 10 nanoseconds, I will change A0 to 1 and A1 to 0. Then I hold another 10 nanoseconds, and the next I have to check what's the value, 0, and A1 should be 1, right? And then we hold for another 10 seconds, and I will assign 1 and 1 to both inputs. Okay.
Will you have to hold 10 seconds after?
After that, A1 and A0 will be held to be 1. unless you add something else to change the value. Okay. So when we are done with this, we have to go to the left side, and it's a little bit tricky here. We have to change the sources for option to behavioral simulation. So if we change the drop-down list from implementation to simulation, then the library, the design will look a little bit different. So on the top level, we have this test bench. So I double-click it. It's going to be the program we wrote. And the second level is the real chip we designed. So we double-click it. We'll have the schematic, right? So go back to design. And now I highlight this. If I expand the bottom side, I have the option to check the syntax. This means to check the program if my code is correct, any syntax error on my code. So I double click this, and I have this green check, which means everything's alright. And on the bottom side, it tells us check syntax completed successfully, right? After that, I double click the second one, simulate. So if we wait for a little while, we can see this window. And basically, this part is what we are interested in. And when you submit your project, you have to either do screen capture or print this out for the waveform, okay? And here we can see we have the input A0 and A1, and we have the output D0, D1, D2, D3. And I can use the full screen. So the horizontal axis means the time. So we started from 0 picosecond, and eventually we come to 500,000 picosecond. And the change of the waveform happened at the beginning because we specified that the change happens for every 10 nanosecond, right? Does that make sense? Okay, so one thing to mention is one nanosecond means 10 to negative 9 seconds. How about 1 picosecond? Negative 12. Okay. Does this make sense? I hope I am correct. Okay, so at this location, it's actually 1,000 picosecond is equivalent to 1 nanosecond. Oops. Am I correct? Okay, yeah. So right here, it's already 500 nanoseconds. The time is too long. Remember, the change happened after 10 nanoseconds, right? So we don't have to simulate for such a long time. What we can do is we can go back on the simulate tab. You right-click it and choose process property. And here you can change the simulation runtime. And in this case, I believe just 100 nanosecond will be good enough. Click OK. And now I double click it to simulate again. Okay, so now we have a little bit better view of how the waveform changes, right? And you can use the button, the left arrow and right arrow to move this line. And wherever the line is on this column, it will show the value of the line. And you can also use the mouse to precisely move this line to the location you are interested. So for example, if I move the line here, and along the line we have A0, A1, they are both zeros. And from D0 to D3 we have 1, 0, 0, 0. So it's already shown here, 1, 0, 0, 0. And let's check if this makes sense. So if A1, A0, they are both zeros, then output will be 1, 0, 0, 0, right? So, and we can move it to the next state. Here, A1, A0 is 0, 1, and output will be 0, 0, 1, 0. So we have 0, 1 as the input, and the output from D3 to D0 will be 0, 0, 1, 0. Does this make sense? So simulation gives us the correct result, which means our design is correct. There is no mistake. And here, if A1, A0 is 1, 0, then output will be from D3 to D0, it's going to be 0, 1, 0, 0. So from D3 to D2, it's going to be 0, 1, 0, 0. Also correct, right? And finally, you can move it to here, and oops. The output will be 1, 0, 0, 0. So with this, you actually you are pretty much done with your project. So again, here in this demonstration, we designed a 2 to 4 decoder, but for the project you have to design a 3 to 8 decoder. It's different. So for 3 to 8 decoder, remember to download the course notes chapter 3 part 2, and the 3 to 8 decoder is right here on page number 11. Okay.
Is that the one we're supposed to do right there?
Yeah, this is what you are supposed to implement in the schematic. Okay, and when you simulate it, it's gonna be more complicated. In this case, you have 3 inputs. So if you have 3 inputs, you have to here you have to assign the value to the 3 different inputs, right? Accordingly. And also you have to hold for 15 nanoseconds in this case. After that, remember to submit your schematic, your test file, your waveform, and remember to put your name on the schematic, all right? And a smile face maybe. Okay, so yes.
When are you going to put up chapter 3 part 2?
I haven't uploaded yet, but I will do it right after the class.
Okay.
Is this okay? All right, and actually we will start with chapter 3 on Thursday. So pretty much, very likely we are going to look at the decoders on Thursday. All right.
Where did you go to change the nanoseconds?
The nanosecond. On the top side, you can specify the unit. So here the unit is nanosecond, and here the number sign followed by a number. This number will be the hold time, and in this case, this means 10 nanosecond. So this means hold for 10 nanosecond. So when you work on the project, you have to change this from 10 to 15. Okay? Yes.
For the test file that you're saying, is it just the code that it gives us, or what
Right.
do you think it?
For the test file, it's just gonna be the code. So you can copy paste this code into Word or anything you like to print it out.
Okay.
Okay.
Do you need us to comment the code?
Yes, if you can provide comments, that's gonna be much better. But if you don't, that's also fine. Also remember, on the top side, you can comment it and write down who wrote this code. Okay.
And then where do you go to change the amount of picoseconds in the range?
Okay, when you change the simulation range, go to here, right click, and choose process properties, and here you can choose how long you are going to do the simulation. Okay, yes.
So there are computers in the electrical computer engineering building we can use?
Right. There are computers in the electrical engineering building. You can do this. So if you don't have the software installed on your laptop, you can do it in the computer lab. One thing might happen is the license may expire every 1 year. So if you use the computer and it tells you the license has expired, you have to do the same thing. Go to Start, Program, Xilinx, and choose the Manage Xilinx license. Then you either generate the license from Xilinx website or you download it from Blackboard, and you have to click this button, Copy License, to get a new license. All right. The license I posted on Blackboard was generated yesterday, so for sure it's gonna be good for you throughout the semester. All right. Any other question? No? Okay, great. Then let's look at a little bit on the exam. So first of all, is there any question you want me to discuss? Any problem?
You recorded like a screen copy of what you did into.
Uh-huh.